Hello, my name is Cameron Fuller, and I am a solution director with Quisitive. And I'm looking forward to getting a chance to introduce you to our monitoring solution that we call EverWatch. So it's a quick walk through what we're going to talk about today. We're going to introduce EverWatch. We're going to talk about how it works. We're going to talk about how our Quisitive team actually uses it for monitoring of alerts, how we go beyond just basic monitoring with EverWatch, and take a quick tour through it. So let's get into it. So common questions or common situations that we've got in customer environments are things like, are your systems sluggish or not very responsive? Are you spending too much money on it? And is your Azure subscriptions costing you more than you would expect that they should be costing you? Or how can you tell if something truly strange is occurring in your environment? That's why we actually developed the Everwatch solution. Our goal is to be able to go beyond the traditional monitoring solutions. So we've developed great capacities, not only on the general monitoring, but also to be able to do things like identifying constrained resources, systems that are performing badly because they're low on resources. Or the other side of the equation, overallocated resources, because overallocated resources are costing you more money than they need to be. You can also watch your environment and see if there are anomalies or unusual situations that occur within your environment that are called anomalies. So with Everwatch, what we can do is we can help you to stay ahead of the curve. We want to make sure that your systems are operating where you want them to be able to operate and how you want them to be able to be operating. And our goal is to really revolutionize the way that you manage your resources within your environment. And I should also mention that even though this is a cloud-based solution, we don't just monitor cloud-based systems. Because we work on the Microsoft ecosystem, we can monitor not only your environment that resources that exist in Azure, but also things that are on-prem or potentially in other clouds. So with that, let's talk about what Everwatch is and kind of how it fits into the spectrum of what we do here at Quisitive. So at Quisitive, we have a solution called Azure Management Services, and the focus of that is again to be able to provide management of your Azure resources, on-prem resources, and other cloud resources using the Azure-based framework. So we've got four major components in this: operations, security, compliance, and automation. Today, we're going to be focusing on the operational aspect of this. So this is how does our team effectively take signals from what's going on within your Azure environment and let you know the things that you need to know about. So how we do that is we leverage, as I mentioned, the monitoring pane that is available within Azure. We use a series of different components. We use log analytics, and all of this, by the way, exists within your tenant. So the data stays in your tenant other than alerts that are sent out in the environment. Data stays local. So what that allows you to be able to do is you can see the same information that we see. So log analytics provides an immutable data storage that we can actually put data into, that we look through and find what alerts are occurring within your environment or patterns or trends. We use Azure monitoring and VM Insights to be able to take a look at what's occurring within your virtual machines, as an example, and Azure Monitor to be able to generate alerts. Use Azure Policy to be able to enforce best practices, to be able to push out things like, these are the types of resources that we're going to monitor. Here's the data that we're going to collect that's going to write into log analytics and the rest. We use logic apps and function apps to be able to do a series of different automations for us. And we also use within Azure Monitor things like action groups. So that allows us to be able to provide notices to our team of whenever different situations are occurring within your environment that are relevant that need to be notified about. We use application insights, we use Azure Automation and Key Vault, and then we also use Grafana for visualization, which is what we'll showcase here on several of the slides and actually pieces in the demo at the end. So how Everwatch works. So what it is it's an Azure-based solution that what we do is we have a policy that's set on the management group level. It gathers information from different subscriptions, from your different services that you've got here. You see, as an example, app services or virtual machines or SQL servers, your Azure Active Directory. Writes all of that information into a log analytics workspace, which then generates alerts. It has a process that we use called the alert processor and our rules engine. And what they actually do is we take a look at all of that data that we've gathered up together and we say, okay, what in this information is relevant? What could potentially be a duplicate? what information needs to be forwarded on or could potentially be suppressed. So as an example, we use tags to be able to identify, say, a development resource, which may not be important enough to notify if it's got a heartbeat level failure. So those are how we use the rules engine to be able to weed through the various alerts that are coming out of Azure. And then we only escalate the things that are relevant enough to our AMS team on the monitoring side for human personnel to be able to take a look at that and figure out, hey, what's going on? Is there something that we need to fix or something potentially to escalate to the customer? We've got some anomaly checking in there as well to be able to take a look, as I mentioned, and see if something unusual is occurring in the environment. So here's how we monitor alerts. So we've got this structure that's in place. We pulled all this data together in these different environments. Well, we need to be able to look across all of our different customers at any one point in time and see what's occurring. So this is an example from a dashboard that we use internally, which is only showing current customers that have active alerts at that moment in time. Provides us with a single dashboard, single pane of glass for all of our different subject matter experts on the monitoring space to be able to take a look, see what's going on, and to be able to identify again issues that may require either escalation to your team or potentially to our coaches. So coach is actually first. So as part of this, we have a monitoring team that's part of the solution, but we've also got an Azure coach, somebody who understands Azure and knows how to work with it on a daily basis. So we will most often escalate first to your coach if there's a situation that's occurring, something that they can potentially resolve, and then only really bring it to you in your organization if it's something that we're unable to resolve for some issue, for some reason. So quick look at this, you can see what we see, different types of alerts that are occurring, things like high disk queuing, high memory usage, CPUs, critical, things like that, as well as things related to VPN or virtual network gateways, and all sorts of different resources that are out there. So one of the things that we talked about earlier on as we started the conversation on this is that the goal of Everwatch is not just to provide monitoring. We want to go provide you with that monitoring and let you know what's going on and also give you visualization so you can tell what's going on and and visualization for our team. But we also want to look forward beyond just monitoring. So what we've been looking at is how to add capabilities around constrained resources. So as an example, we'll take virtual machines, which are a common area of constrained resources. So you see, if we take a look, the CPU one up top shows a red line where there's a threshold level that we're going above and beyond that indicates a problem. So we can look over history on that particular resource, and our team can use pattern recognition to identify, is this a system that is regularly, as an example, hitting and sustaining a high CPU? The example shown here, it's not hitting and sustaining, it's a hit and release, which is not necessarily a big deal. But if it's something where it hits and then holds for a period of time, that indicates a potential constrained resource or CPU bottleneck. Same thing on memory, but if we look at this one, it's kind of in reverse, that we're looking at when we're running out of memory. So the red line is at the bottom of it. This particular system is hitting and hitting it pretty regularly. So it may very well be a system that needs additional memory on it. And then disk space is extremely important. You don't want to run out of disk space, especially on the operating system disk, because that can cause all sorts of problems with your operating systems. So we look for those and for patterns on those as well when they're hitting a very low disk condition. So we can do things to be able to address that before it runs out of disk space. So on the other side of the equation, we also look at over allocated resources, which is systems that have been given too many resources that you're paying for that you may not need. So we look at memory as an example. So systems that have available memory that is available on a regular basis that's not being used. We prioritize those by the highest level so we can see which ones have the most most available memory. Same thing on the disk side of things. You can over provision a disk. If there's too much space there, it's space that you're paying for on a monthly basis. It might be something that we could go ahead and decrease the amount of disk space that's on there to be able to handle it. We're also looking at it from a CPU side. If you have a system that is highly allocated from a CPU perspective, but it's not using it, it's wasted CPU cycles that you're paying for as part of the particular SKU that has been chosen within Azure itself. So we also look at anomalies. Things like what is normal behavior, what is a change in behavior. So, as an example, in this one, there are different anomaly scores that are shown. So, a large anomaly increase indicates the fact that a condition that occurs sometimes is now occurring much more frequently. So, as an example, cost advisories. In this one here, we see a 36 is an anomaly score. Expect about 0 alerts, and we got about 14 alerts. That indicates something is occurring on the cost side from a cost advisory perspective that's different. We also look at the negative anomaly scores. We can look at this to be able to determine if there are patterns that we need to address or just patterns that things are going well and we're making good changes within the environment. So as an example, in the second graphic on this one, we see that the proactive disk space has gone from 3 expected alerts up to 73 alerts. So what we're actually seeing in the second half is also an increase, but it's an increase that it's showing us that that is a large anomaly score, which is a result of the fact that we only expected 3 alerts, we got 73. Well, that's pretty important. So we're seeing a whole lot more proactive disk space alerts. There's something there that we need to be paying attention to. So both of the examples here are showcasing where we have a higher volume of expected or alerts that actually occurred versus what's expected. But we also, again, do look at the negative anomaly score portions of it because it can help us to identify trends there as well. So with that, one of the things that we've gotten feedback from our customers on is it's important for you as a customer to be able to see what's occurring within your environment as well. So you've seen several of the different screenshots that I showed you are from a solution called Grafana. We're using Grafana as well to be able to provide this type of visualization. So what we've got in here is a series of different types of visualizations depending upon what you've got in your environment. So as an example here, this is a top level dashboard where we can see common alert trend right now. So this particular demo environment, we have a set of errors that have occurred. They have increased and there's a trend upward at this point in time. So the way that Grafana works, we can actually drill in. If I click on that button, that will actually bring me into details, or if I click into details here, it will actually open it up in Azure. But we can see across the board that these are the ability to look across multiple different types of things in one quick user experience. So we can look at alerts here, virtual machine performance, app service, SQL SAS, function applications, patch management. So this is part of our automation platform, one of those 4 pillars that I mentioned on the AMS slide here. But in this piece, I can actually see what your patching looks like from an endpoint perspective or server perspective. And then security is always extremely important. We get that. So this gives us the ability to be able to look across your security information and take a look at incidents and alerts and risky users, as well as secure scores over time and see what patterns look like on those fronts. So all of those, give a quick level view, C-level view potentially of what's occurring within your environment. Those all then, as I mentioned, they can all be drilled down. So I can take a look here at a virtual machine metrics and I can see in here how many systems don't have a heartbeat right now, and then the list of what those systems are. If there's any that are memory or CPU or disk bound, as an example, they'll appear here. So I've got a disk here with 0% free on an E drive. That's a problem. So we want to take a look at that, see what we need to be able to do to resolve that particular situation. So we can also look at over allocated systems. This is, as I mentioned in some of the screenshots here, here's an example of a different E drive that is only using a small percentage of it, and has 509 gigs of free space available on it. We're only using a small percent. That could be one that we would look at and take a see, does it make sense for us to go out there and make changes that would allow us to decrease the usage associated with that, take it down to a lower level, something less that you're paying for on a monthly basis. And then SQL. Let's take a quick look at SQL SAS as an example. This one showcases how many are available versus anything that's offline, gives you current session count, any bound metrics again, memory, CPU, or DTU as an example here. Shows us the availability of these different systems and when things change during the day. So it gives us good details of what's going on here. And again, and then all the metrics that are available, we can break out CPU, DTU, memory, storage, anything else. So our goal, stepping back on this, is wanted to be able to give you and your organization visualization to be able to see what's going on within your environment. So top level dashboards that are drillable down into details and are also then drillable down into details from an Azure perspective as well. So hopefully that was interesting. This is your quick tour of Everwatch. If you got any questions, please feel free to reach out to us. We would be glad to have a conversation with you about it and show you what we can do to help your particular environment. Y'all have a great day. Thanks, everybody. Bye.